Hello, this video is related to the advanced cam design and the basic data we're going to be using for today's session. It's the one that it's already on Blackboard. It's the following problem you have on this course. It says a follower is standing dual from 0 to 45 degrees. There's a period of 45 degrees where the cam is going to be just standing without any increasing or decreasing the radius. Then it moves outwards 2 inches with harmonic motion, uh, and then it returns to the original position, and then once again dwells for 30 degrees, and then it moves outwards 0.5 inches, and on and on and on. All this information will be fed on Excel that it's already also on Blackboard. I'm showing you this information here. I'm helping you a little bit, including the formulas of the cycloidal motion, increasing and decreasing, and the harmonic motion. That is also here on this page. Also, there's a table where you can see span, which is a period of degrees that we are having duals or increasing or decreasing, and then the basic radius and the length number 1 and length number 2, and on. Well, to start on this information, please check that the follower is standing dual for 45 degrees. So on our Excel, we're gonna type 0 to 45. In this case, we don't have beta because we're not using any formula at all. Action, we type dwell, distance 0, and curve hyphens. We don't have any curve at all. Then next step is from the next of 105 degrees, it moves outwards 2 inches. So from 45 to 150 degrees, we have a beta of 105 degrees, and the action is increased. The distance is 2 inches, and the curve, according to our data, it's harmonic motion. Since it is increasing, harmonic motion is h5. Then it says it then returns to the original position inwards 2 inches during the next 90 degrees uses cycloidal motion. Well, it means from 150 to 240 with the 90 degrees of beta. According to this, it says cycloidal motion decrease 2 inches. Okay, and then C6, which is a cycloidal for decreasing. Then it says it dwells 30 degrees. Okay, from 240 to 270, no beta at all. Let me type hyphen and then dwell. Distance 0 and curve nothing. Okay. Then it says that I'm using for the following 50 degrees. It moves outwards 0.5 inches with cycloidal motion. So let me see once again. It's 50 degrees from 270 to 320. It's 50 degrees increase. Distance 0.5 and It's a cyclotron motion, so it's C5. And then for 40 degrees to finish the whole 360, from 320 to 360, 40 degrees, we're going to have 8 degrees of 0.5 degrees with a curve of C6. Okay, the radius, according to our information, is 0.75. I mean, diameter is 0.75. No. Radius, basic radius of the cam, 1.5, excuse me. 1.5 for the radius. And then L1, which is the first increase, it's 2 inches. And L2 is 0.5 inches. The velocity of the cam is 0.5 revolutions per second. And the delta, according to this information, delta T, it's the delta of the angles we're going to be using here. It's 5, 5, 5, and 5. And the omega, it has to be converted to degrees per second. So the delta is 5 over omega, it's 0.5 revolutions per second. 0.5 times 360, because every revolution has 360. And that's all. Okay. And then we put equal. Okay. Okay, let's start with the S from 0 to 45. 0, copy, and paste formula, or paste values, it's okay. Okay, escape, save. Then it says from 45 to 150, we have an increase of 2 inches using H5. H5 is here. I can just do this just to help a little bit. And you know what? I will suggest you to freeze the panels in view, freeze panels, so you can have the values of S, X, Y, and Z, and on, without moving a lot all the pages. So paste these formulas. I'm going to cut it a little bit. Let me okay. I see crop. It's okay. No problem. We have it here. And let's see. It's S equal L over 2. So equal L, which is the first one. And using dollar signs, because it's constant, over 2 times 1 minus, open parenthesis, cosine. We don't have to convert because it's degrees and degrees. So pi, open and close, you see it's pi, times the angle. Remember, this is phi that will be moving from 0 to beta. But in this case, the difference of the angle is theta, which is going to be this value. You see it? C43 minus all the angles that are previously defined, 45 degrees, okay, over beta. The beta is already here, 105, also constant, and closed. See, it's closed. Okay, cosine. Very good. And you see, since the formula has to be starting from 45, in this case, it has to be 0 here, and here it's 0.11. It has to be finishing on 2, where? In 150. So we paste to 150, paste the formula, and you see it finishes on 2. Okay? Okay, let's take this out. Okay. And then the next step is to decrease. As we can see here, it's a C6 curve. Okay. Let's unfreeze the panels and take the C6 curve, copy. Once again, move a little bit, place curve mouse on this place, and then freeze panels again. Oh, let me do it again. View, unfreeze, and then here. View, freeze panels, okay? And then let's work here. Okay. Paste, C6. Then it's, let me increase it a little bit. Equal L, which is C29 constant. Let me open and close parentheses. 1 minus, open parentheses, 5, which is going to be this value. Okay. C64 minus, you can see here, previously, we're going to start here, it's 150, 150. All the degrees are before this point, over beta, and beta is an angle that is defined exactly here, 90 degrees. We can just separate these points, open and close parentheses, and plus 1 over, open parentheses, 2 times pi, and close, times sine, okay, 2 times pi, times, open parentheses, and once again, C64 minus 150, open parentheses, over beta, and beta it's 90 degrees, also a constant. Last time we didn't use a constant, so let me use it here. Give me a second. C23 it's constant. Beta, we see beta 5 664 minus 150, 1 5 beta 1 over 2 pi sine 2 times pi. Okay, that's it. Okay, a little bit less than 2, and I copy the formulas, and will be until 240. 340, paste the formula, has to be finished on 0, it's okay. Then it dwells for 30 degrees, okay. So it's 0, copy, and then paste to 270, paste the values, escape, save, and then increase on the next 50 degrees. Let me unfreeze the panels, and it says it will increase 0.5 inches using the cycloidal number 5. Okay, so let's copy this formula. Let me see if it is the case. Increasing, no, harmonic. Okay, increasing cycloidal and finishing on harmonic. So I think I have to change this to H6. Okay, and C5. Okay, once again, freeze the panels. And then go again all the way down. Let me erase this all the way down to part of the analysis. Let's increase this C5, and you'll see from 270 to 320. Let's use C5 and equal L. In this case, L will be L2. Okay, times then phi, that is this C85. Okay, minus 270 over beta. In this case, beta it's 40 degrees. It's a constant. It's important to separate these into an independent analysis, or it's another parenthesis and another one. Minus 1 over open parenthesis 2 times pi. Okay, times, let me see, it's increasing this, times sine 2 times pi times open parenthesis C88, which is phi, C88, minus 320. I think last time I made a mistake. It's okay. Now it's increasing 270. But I think, okay, it's okay. The beta in this case has to be C25. C25. Okay. Okay, let's change this beta C25, and then let's over C25 dollar sign, close parenthesis, close parenthesis. Okay. Okay, we have phi, which is C88 minus 270 degrees, over beta, which is C25, minus 1 over 2 pi sine times pi, which is C88 minus 270 degrees, and then C25. It's okay. And on. Okay, it's increasing. Let's copy this until 320. Paste formula. Okay, it's increasing to 0.5. Escape. Save it. Okay. And then we're going to have decrease using H6. Okay. H6 is this formula. So let's move all the way down to 320. And then let me increase this size. Equal, open parenthesis L, now it is L2, dollar sign, over 2, Let me close over 2. Okay. And then times 1 plus cosine pi times phi. In this case, phi is C98 minus 320 over beta, which is 40 degrees, dollar sign, okay. Close parentheses again, and close to a full, let me see, okay. Enter, copy the formula, and paste formula all the way down until 0. Here we have all the points of S. Let me unfreeze the panels. And these are going to be the basic of the profile of the cam. So for the X, we have to go to the radius, which is a constant, plus S, and then cosine. And since theta is on degrees, let's convert to radians. Theta is C33. That's it, 1.5, the first value. Okay. Copy, and then paste the formula all the way down to 360. Paste the formula. And it's the same formula, but using sign for the case of Z. So copy from this cell the value of X, escape, and paste it on Z by changing from cosine to sine. Enter. Copy and paste all the way down to 360. Paste the formula. Escape. As you can see, we're going to be using the from plane on an X. So that's why we are going to be using X for the horizontal coordinate and Z for the vertical coordinate, and Y it's going to be 0 on all the cases. So copy and paste all the values, 0, save it. What about the value of T? Delta T, the first one is 0 because we start 0. S it's equal to the values S equal 3. So copy and paste all the way down to 360. Give me a second. Paste formulas. In this case, the delta T is equal, then the second cell is equal the value of delta T. And the next one is a previous value plus the delta T as a constant. So you're going to be increasing a constant value to the previous value of the time. Copy and then paste the formula so you have 2 seconds at the end. Okay. If I have 0.5 revolutions every second, I'm going to need 2 seconds in this case. Okay, let me continue. If every second I have 0.5 revolutions, I need 2 seconds to have a full revolution. Okay, let me save this and let's continue with the next and next. And okay, give me a second. Okay, so we're gonna create a new, choose a directory you want to use. In my case, I'm gonna use this one, 53 cam design. Okay, give me a second, I have to choose it. Okay, and then 01 advanced cam. Okay, we're using inches in the model case for designing, it's okay. And then let's go to insert. I think, okay. Go to insert and let's check uh, curves. Let me see, we can use spline command. Remember the one we're going to be using, it's spline to be retired. Okay. Give me a second to connect to the battery. Give me a second. Okay. Okay. Then you have to choose through points from file. Oh, give me a second. I need to create another important part from here. That is the points. So let's create in the folder you want a text document, CO1 cam design. Double click on it and copy from the Excel file all the X, Y, and Z values. Copy and then paste all of them. Save and then save as the same value but the extension DAT, extension dot. Save because it's the only extension that NX recognizes. So points from file, desktop, or in my case, okay, cam design, and then cam design. Curve degree, it's okay if it is 3. Okay, okay. So what you have here, it's this profile of the cam. As something that I really suggest you, it's to create an extra sketch to see the changes that were previously defined into the data. So go to sketch, touch this XZ plane, more unselect continuous auto dimensioning, create a circle. It has to be a diameter of, let me see, radial dimension, diameter of 3. Okay. And let's convert this to reference. Let's hide this. And then create all the lines that were used to define all the sections of the cam. Okay, so you can see on this vita, it's first 45 degrees, so angular dimension 45 degrees, and then 105. Okay, and then let me see next one, it's 90 degrees. Okay, 45, 105, 90 degrees, and then 30 degrees. Okay, and then let me create another one. This section is 50 degrees, and the other one has to be 40. Okay, we cut all of them. Let me create this dimension, because in this case, this one has to be 1.5 plus 2. Okay, 3.5. And then this has to be 1.5 plus 0.5, 2. Okay, and then this, let me see if it can be cut. Okay, and then all of them will be converted to reference. Okay, we can showing hide all the PMI objects. Then you can have all the sections you used to create